as Professor Teresa mentioned, my work is a joint work with Professor Filomena Teodoro, and we are trying to measure and to evaluate the quality service in Portuguese electricity continuity indicators. I'll try to be brief, but sorry. So I'll start with a short introduction, refer some methodology and the data and some results, and our conclusions. So, well, we are, this data is from Redes, which is the primary operator in the Portuguese mainland electricity distribution, and with the service of high, medium, and low voltage electricity, and which is serving over 6 million customers. And each year, the distribution network operator must record and analyze the number of interruptions, of total interruption, and the duration of those interruption services in electric points in the market, either they are companies or private. So this is a point of interest, not only because of the customers, either they are companies or private customers, but also has the problem of fulfill requirements of service. And in November 2022, the Redes launched this open data portal to share the relevant data from its operations, because they want to embrace the transparency with the community and also act as a catalyst for the country's energy transition. So there are more than these indicators, but now we are focused on these indicators because the electric utilities, of course, want to serve high service continuity and maintain the customers' trust and complying with the government regulations. So when we observe frequent or prolonged cuts, outage, that can be significantly inconvenient to the customers and to reduce the productivity in commercial and industrial sectors, and even to pose some public safety risks. And we decided to observe these two continuity indicators, as I've mentioned, which is the system average interruption frequency, so the medium of the average of the number of interruptions in the system, and also the system average interruption durations, for how long those interruptions are occurring. And these are international indexes. And here in this work, we just consider these indexes for medium voltage and low voltage systems, because we have data from 2014 to 2022, recording the accident and the planned interruptions on the system. And we, when analyzing the data, we have thought of analyzing it with two-way ANOVA. And considering two different factors. One factor, the quality service regulation zones, because the main country is divided in four quality service regulation zones, and also in municipality codes, which will be factor B. And we just want to see the continuous variables outcomes, these SAIFI and SAIDI indexes, measures for the medium and low voltage. So the first step was to identify if the factors influence the variables of interest. And the idea was to use ANOVA to test groups' differences by comparing means of each group and including the distribution of variance between the multiple origins. And we have described our model for each variable, psi if medium voltage and psi if SAI5 low voltage, and the same as SAIDI medium and low voltage. We have 4 models like this. So the variable will be equal to the mean, the global mean, plus alpha I plus beta j plus gamma ij plus this epsilon ijr, which will be the error, in which the alpha I will be the effect of the quality service regulation zones, and the beta j will be the effect of the municipality code. This term, the gamma ij, will measure if there is interaction between the factors. If we don't have significant interaction, then the model and the interpretations are simple, because we say that the model is additive and the effects of each of the factors are just adding in the model. So, as I've mentioned, we have these variable indexes for the medium and low voltage, and 9 years of observation registered this frequency and the duration of the interruptions. The mentioned factor A, quality service regulation zones, has is divided in zone A, zone B, zone C, and also has a category which is the municipality, which refers to the center of the town or the village. It depends, because these zones A, B, and C are dividing the number of customers. So zone A is up to 25,000. Then zone B is between 25,000 to 2015, and then which is lower, of course, and then zone C are the shorter number of customers. But they also record the center of the municipality, which in general has more customers, especially the private. And for the second factor, the factor B, we have 35 municipality codes for each case. Okay, so we have started with a brief analysis for the variables. The frequency for the medium voltage and the low voltage, the frequencies are in these violin graphs represented here. The duration of each for the medium and for the low voltage are represented here. We can see similarities, but also some differences, and we can see that there are some observations that are discordant. We also have decided to plot the box plots for each the municipality codes, which are presented here along the graph for the different categories of factor A. And here we just presented the box plot graphs for the frequency index for the medium and the low voltage case. And of course, we see that they are very different, and they present in many different ways discordant observations. And this was, for us, interesting and a challenge. We have also tried to measure the duration, to graph the duration in indexes for the medium and the low voltage, and we can have them here. So we run the model, the two-way factor model, and we can observe that in the first run we have observed that the interaction is not significant, which were good news. And we can just try to see what to conclude with the additive model. So we run the additive model, and the factors were significant, and this was interesting. The problem was, and it was already noticed by us, that we have in this data, which are real data, of course, very discordant observations, and there is not a pattern or anything. So we have, when we started the descriptive analysis, we noticed that we would be having a problem. And these several discordant observations also have to be studied. And we think that because of them, but not also because of them, but there are possibly other problems. We don't observe normality of data, and consequently, we don't have the homogeneity of the variability, which means that in conclusion, we have some lots of problems with the model because we cannot conclude a lot, because we need to study what are those values be doing there, and what are their contributions for the data. So we decided to use data transformation, the square root, because we cannot use the logarithm because we have lots of zeros. But with the square root, the results were smooth. The problems were a little bit smoother, but they were still there. And then we decided to square the standardized values within each of the factors, the quality service regulation zone and the municipality code, and then run again the analysis. So we started to the square of the standardized values, because we need to have positive values, of course. And in the first graphs, we have the frequency and the duration of the interruptions for the medium voltage, considering the interaction. And we can see that there are some peaks within the municipality codes. But since the interaction was not significant, we decided to run the model without interaction, the additive model. And the interesting was that the first factor, the lines are almost overlapped, so we could identify which are the critical municipality codes that need to be observed. So for the frequency, we have the peaks here, and the bigger peaks here and here and here. But for the duration, the peaks are in different locations of the municipality codes. And this is interesting. So we need to continue to study this data. What I have done yesterday after receiving this invitation was to check. I'm going to try is if I can share this here. So Can you see it?
Okay.
Can you? No.
Wait,
Share.
let me
Are
make.
you seeing it now?
Yes, yes.
Okay, so I just tried to see to use the software, and I think we can. Well, I don't have much done with this, but I think we can possibly use this to visualize the critical problems, because what I'm just showing these data, these graphs, and then electricity interruptions are very important for the companies and also for the consumers, either they are companies, commercial, or even for the safety, public safety risks. So we need to treat those data before we can proceed with our analysis. And what we have already seen with this transformation data and is that there are some areas in the municipality codes that need to be observed, which we would like to present some ideas to the company so they can consider them for a different treatment. What we observed also here in this study is that the first factor, the quality safe regulation zone, may be seen as a vertical overview of the country, and the different municipality codes may be for this in each of these vertical categories. The horizontal subject that needs to be treated. So we want to continue to explore this and to help the company to identify which are the important places in which to take measures, and all, of course, to so that they can offer a better service, and in order to fulfill the international laws and regulations that they are aware. So this was our work here, and I just left here